Welcome back to another episode of Derivatives Examples, where I basically run through examples and show you how to do them. I've explained in each video before, and I'll explain again, that I will make each set increasingly harder, so by the later videos they should be quite difficult. But on these first couple, they should be relatively easy. Now, for those who understand derivatives, for those who are learning, this will be helpful, because I know the best way that I learned how to do derivatives was by watching people, or by just picking up on techniques as I watched it. Because the more you do something, or when you watch something, you're bound to pick it up. So the more you do it and the more you focus on it, the better you will get at it generally. So I will go through these three. If you don't want to watch these, you don't have to watch these. If you think that you might learn something from these, by all means watch. Now that's a bit messy, but that's a 3x, and that is a sine x. I'm not very good at handwriting. Like I said before in another video, I am a mathematician, not anything really else. But on that note, let's start with example 1. Example 1 says y equals x squared multiplied by sine x. Okay, so I'm not going to do notation here, but I am going to do a quicker way of doing the product rule, because we're going to need it, because we have a function multiplied by another function. We have our u and our v, just like how we would with proper notation, but I'm going to skip all writing it down, and I'm just going to write out the quick method, which is u dash v plus u v dash. Basically says the derivative of u multiplied by v plus u multiplied by the derivative of v. And we're just going to do it as we come up to it. So, y dash equals u dash. If x, I'll point them out. If x squared is u, then the derivative of x squared would be 2x. Next we have to multiply it by v. V is sine x. Then we add it to u, x squared, and then we multiply that to v dash. V is sine x, so the derivative of sine x is cosine of x. Now I'm just gonna rewrite it without the multiplications, just to make it look neater, somewhat neater. But that is the derivative of this function up here. Now I'll go on to the second example. Example 2. Okay, y equals e to the power of 3x. Now this is going to be one step, because there's a rule for this. And this one step is going to be 3e3x. Now the rule is, when you have y equals e to the power of kx, when you derive that, you get k e to the kx. Now that's because when you derive e, when you derive e to the power of x, or e to the power of a number of x, you still end up, see how these bits look the exact same? That's because no matter how many times you derive it, you'll still end up with this exact same little bit added on. It's just, it's multiplied by the derivative of this little inside bit up here. And because 3x, the derivative of 3x is 3, you end up with 3 multiplied to e3x, following this rule. And that's it. I'll go on to the second example. Now, the third example, final example. Example 3, which says y equals 10x multiplied by sec x. not the derivative, just y on its own, we have our u, we have our v. Like I said before, the quick way, it's u dash multiplied by v plus u multiplied by v dash. This rule should be in your textbook. I don't expect a long one to be in your textbook or proper notation, but usually if people are doing it Leibniz's way, they'll just do it this and write out this. Well, it's in the back of 2 of my textbooks, I know that now. Anyway, let's fill it in as we go. U dash. If u is tan x, then derivative of tan x is sec squared of x. V. If v is sec x, then we write sec x. Then we add u. If u is tan x, then we write tan x. The derivative of v, if v is sec x, I'm going to write it down here because I'm running out of room, but the derivative of sec x is tan x sec x. And that might seem a little bit confusing. That's a multiplication because I'm multiplying it to this. But when you derive tan x, you get sec squared x. If you derive sec x, you get tan x sec x. It's just how it is. I'll do a proof video on that, but I'm not going to explain why that is now. So we're going to simplify it. Sec squared multiplied by sec to the power of 1. There's an imaginary 1 written there. Now it's real, obviously, because I wrote it, but we'll just add the powers, which will be sec, that's poor, sec cubed x plus tan x multiplied by tan x is tan squared x multiplied by sec x. And that there is your derivative, first derivative of this function up here. Thanks for watching. I hope this video helped. Leave comments telling me how I can do better or bring this videos across, because I've never done anything really like this before this YouTube channel. But anyway, thanks for watching. Have a good day.